So I love boxes, by the way. This is a box for holding stuff, but it's also a box. So this is the original building that they gave to us. And you'll probably look at that and say, yeah, that's fine. Right? No worries, everything's cool. But what you might notice is that there's not many return walls in this. So when you think of the most efficient building that you could possibly build, it's this, right? It's a box without any windows and doors, right? Probably not going to win any architectural awards, but that's the most efficient thing. Any movement or deviation away from this is a compromise, right? It's going to cost you money. It's going to cost you time and effort, right? So that's what you want to build, right? Now, putting windows and doors, probably not too big a deal, right? Of course, windows are more expensive than just a solid wall, right? But putting windows and doors in structurally, if we just think about the structure, putting windows and doors probably isn't too big a deal. Changing the external envelope, shaping a bit, kind of we're stepping away. But there are things that you can do to this box which are devastating. Anyone know what I could do to this box that's devastating?
Remove the whole side.
Sorry?
Remove the whole side.
That is the most devastating thing that you can do to a box, right? Because it's handy for storage, but it ain't handy to hold a building up, right? But look, yeah, there's a return wall here, but look at this. There's nothing magical about buildings, right? This box undergoes the same principles, right, as this building. It has no return walls, so that's what I'm left with, right? So it's completely unstable. So structurally, we need to get this box to be stable. So look at I'm not winning any awards here at all, but this is my model making skills at their best. So, whoa, just a second. So here we go. We're going from something that has no lateral stability, right, to something that is incredibly strong with cross bracing. So, but just a second, how am I going to get through that building, right? So, do you think David thought that was a good idea? Any other ways? Any other ideas? I've got a bunch of others. We already heard one. A staircase to do the bracing?
Yeah.
Love it. The crazy thing is, and I was looking at a picture this morning of a staircase in a building that we're doing with Breakspear, and I was like, that staircase is probably holding the building up. Like, we've got other things happening, but we don't often use, staircases are usually infill. We rarely use them to provide structure. So another option is the steel portal frame. Again, not winning any awards here, but see how effective that is? That's a steel portal frame around the outside, right? And there's obviously one other option, which is probably so obvious that you wouldn't know it, and that is, well, don't cut the ends out, right? So put something inside, right? Put something inside, right? So I went away with these drawings, and I came back to David, and me being compliant structural engineer, right? What do you think I proposed? So here we are. We've got 3 options. There's a few more. But what do you think I proposed? I presented portal frames. Didn't want to disrupt the architecture. I'm a compliant structural engineer. Didn't want to. So that's what I presented. But David didn't like that, right? He goes, geez. So here's the original one, open, right? So we needed to find a solution. The solution that we proposed was steel framed, and David wanted to expose brickwork, and the steel frames were disrupting that. And David goes, are there any other options? And I said, well, we don't have any return walls, so we could put return walls in, right? So I presented this, and I did it reluctantly because I thought, geez, no one's going to accept these return walls in this space, right? Clearly they want this tunnel, right? Well, but guess what David did? Totally embraced it. Right? Anyway, ended up winning the biggest architectural award in New South Wales in 2017.